Lona received a stamp collection from her grandmother. The collection is in a leather book and currently has 120 stamps. Lona joined a stamp club, which sends her 12 new stamps every month. The stamp book holds a maximum of 500 stamps. So let's complete the table at right first. So we know we're going to add 12 each month. So let's see, that's 144 plus 12 would be 156 plus 12, 168 plus 12 is 180. So how many stamps will Lona have 1 year from now? Use mathematical justification when explaining your answer. So you could continue making this table and keep going, 5, 6, 7, 8. Remember, months, in 12 months, that will be in 1 year. So, or we can write an equation. So I'm going to write an equation that says, let's see, I'll let T equal number of stamps. And I'll let M equal number of months. So I know that the number of stamps equals 12 stamps per month, per each month, plus the 120 that she started with. So if I want to know how many stamps you'll have in 1 year, that's 12 months, then I can plug in 12 for M. So I get T equals 12 times 12 plus 120, which is 144 plus 120, which is 264. 264 stamps. Write an equation using function notation to represent the total number of stamps that Lona has in her collection after n months. Let the total be represented by T of n. Oh, so we already did that. So we'll just rewrite it that T of n, so the total amount in n number of months, equals 12n plus 120. Solve your equation from part C for when T of n equals 500. Will Lona be able to fill her book exactly with no stamps remaining? How do you know when will the book be filled? So remember, her book is filled when she has 500 stamps. So we want to know, when does the total equal 500? So 500 equals 12n plus 120. So 12n, n is the number of months. So we'll subtract 120 and we get 380 equals 12n. I'll divide 380 by 12 and we get that n equals 31.66, repeating, which we can round to 0.667 months. So she won't fill it exactly, because after 31 months she won't have exactly 500 yet, but then at 32 months she'll have more than 500. So she won't fill it exactly. Because 31 months won't quite fill it, but 32 months is too much. Use slope to determine whether the points A, B, and C are on the same line. Justify your conclusion. So I know that slope is the change in y over the change in x. So let's look at A to B. So from A to B, my change in y, if I go from A to B, my change in y is 5 to 6. So my change in y is 5 minus 6. My change in x is 3 minus negative 2. So 5 minus 6 is negative 1. 3 minus negative 2 becomes plus positive 2, negative 1/5. From B to C, my change in y over my change in x. Let's see, we go from 6 to 7. So that's 6 minus 7. And then we go from negative 2 minus negative 5. Negative 2 to negative 5. So 6 minus 7 is negative 1. Negative 2 plus 5 is 3. So we have two different slopes. So these points are not on the same line. No, because the slopes are different. Serena wanted to graph the equations below. Rewrite each equation in y equals mx plus b form. Alright, so we need to get y by itself. So the first thing I'm going to do is distribute this negative. So we get 5 minus y plus 2 equals 3x. And then 5 plus 2 is 7. So that's 7 minus y equals 3x. I'll subtract 7 from both sides, and we get negative y equals 3x minus 7. And then I'll just divide by negative 1. So we get y by itself equals negative 3x plus 7. For the second one, I'll distribute the 5. So we get 5x plus 5y equals negative 2. Then I'll subtract 5x from both sides. So 5y equals negative 5x minus 2. Divide by 5. So we get that y is by itself, and it equals negative 5 divided by 5 is negative 1. So negative x minus 2/5. For each graph below, label the key features of the parabola. So here the x-intercepts are 1, 0 and 5, 0. The y-intercept is 0, 5. And the vertex is 3, negative 4. The line of symmetry is right here, and that's at x equals 3. So the equation of this parabola in vertex form, so we know that the vertex is 3, negative 4. So I can use that. So we get that, let's see, y equals a times x minus h, so minus 3 squared, plus k, k is negative 4, so minus 4. I don't know what the a value is, so I'm going to plug in a point that's on my line. So maybe I'll plug in 0, 1 to solve for a, or sorry, 1, 0, plug this point in. So I'll plug in 0 for y, nothing for a, 1 for x. So we get 0 equals a times negative 2 squared minus 4. Negative 2 squared is 4. So 0 equals 4a minus 4. Then I'll add 4 to both sides. So we get 4 equals 4a, divide by 4, and we get that a equals 1. So now we know for sure that a is 1, so we don't have to put it there. So we get y equals x minus 3 squared minus 4. For this one, the x-intercepts are not right there. Right here, there's just 1. So it's at 1, 0, and then we don't have 1. The y-intercept is right here. That's at 0, negative 1. The vertex is the same as this x-intercept. It's at 1, 0. And the line of symmetry is at x equals 1. So now if we want to write the equation of this parabola in vertex form, We get y equals a times x, let's see, minus 1 squared plus 0. We don't know what a is, so let's plug in a point. We can plug in the y-intercept right here. So we get negative 1's y. Negative 1 equals a times x is 0 minus 1 squared. Negative 1 equals a times negative 1 squared. Negative 1 squared is just 1, so a equals negative 1. So the equation of this parabola would be y equals negative x minus 1 squared.